step in like pre-processing in order to basically kind of figure out how you want to proceed with an algorithm and, for example, the type of neural network that you want to use, or all of that. So this is kind of a good introductory step for that. So I think we'll just get started because it's already 3:19. I don't want to start any later. But basically, let's first start off today with, instead of talking about Matplotlib, let's finish talking about NumPy. So yes, last week we quickly brought up, so mainly focused on this library called Pandas last week, if you guys remember, but we briefly talked about NumPy, and we talked about how Pandas is kind of built on top of NumPy to kind of extend its range functionality for larger amounts of data. So if we go take a look at our notebooks, let's launch Jupyter Notebook and wait for this to launch. So in the meantime, I'll give you guys a quick introduction of NumPy. So basically, NumPy is everything. It basically just contains all the functions you need in terms of doing any sort of mathematical operations. So if you're trying to, I guess, perform mathematical operations on like a array, for example, there are a lot of different inbuilt functions into NumPy that are really handy to use. So basically, the main purpose of NumPy is that it's like a mathematical operation calculator for like data structures. That's mainly what it's used for. Of course, there's some other uses of it, but that's kind of like the main one. So pulling up our Jupyter Notebook from last time, share my screen, share. Right, so we went over the second half of this notebook last week, which is kind of went over the basics of Pandas. We're gonna kind of go from the top and start talking about the basics of NumPy. So like Pandas, you import NumPy in a similar way. So you just say like import NumPy, or you can say import NumPy as NP. So these conventions where you say like as something else are just like things you pick up over time. So like you could theoretically name like this import statement as import NumPy as n. And you could just call it, instead of calling it like np.array, you could just say n.array. So you could basically like import NumPy using whatever like keyword or I guess phrase that is easy for you to type, because instead of having to type NumPy dot a function from the NumPy library, you can just type like np dot, which is a lot easier. So that's just something that you guys pick up. So most programmers use abbreviate NumPy as NP and abbreviate Pandas as PD. But yeah. Anyway, so first thing we're going to do is, let's run this cell actually. So first thing we're going to do is we're going to create a one-dimensional array or a vector using NumPy. So if you guys remember back when we started talking about lists, we quickly brought up the fact that lists are like lists in Java and tuples are more like arrays in Java, right? But NumPy actually has like a separate array data structure that you can create using NumPy. And this is basically exactly like what you would expect an array in Java to work like. So you basically pass a size, except instead of passing a size the way you think of it, like doing like in Java, you'd say something like string or something like that, and then you give it a name equals like new string and something, and then you put in like parentheses the size, right? But with NumPy, you basically define your array as either you either define it with values inside of it, or you define it by its shape. So first, let's talk about how we can define it with values. So we just put in a few values here and we print it out. And if you want to get the dimensions, we use this function called ndim. And basically this gives you the dimensions of the array basically. And since this is a 1D array, you'll only see that the dimensions are 1 because it's a one-dimensional array. And if you want to get the shape or the number of columns / comma rows, rows comma columns, it should actually just be like shape or something. Okay. But if you want to get the shape of the array, you just use shape again. So this is the same thing we saw with actually we didn't talk about this yet. So but yeah, use shape to figure out the number of rows and columns associated with it. And for size, which is basically the same thing as like an array.size or size of an array, you basically just use the size function or size like parameter of the NumPy array object. And if you look at the type of the array, you use dtype. So this is important. I don't think we brought this up with pandas, but this also works with pandas. If you want to get the data type of, for example, a row in, I'm sorry, a column in like a data frame, say we had a data frame named, I don't know, df. Okay, this is a data frame and it had some values, right? So we had some values here, and we're basically trying to get the data type of a specific column. You would just like, you'd get the column first. So for example, say the column is called A, and then we would just say .dtype, and we'd get the data type of that column. So the same thing can be done with an array, and we can get the data type of the array. And in this case, it's a float, because remember in Python, there's not going to be like longs and everything else. Anything that has a decimal is just going to be considered a float naturally. And then now we can move on to like a two-dimensional array or a matrix instead of a vector. And if we can do the same functions again, and we get what we expect. We get 2 dimensions. We get the dimensions as 4, 2 of the shape. So 4 rows, right? 1, 2, 3, 4, and 2 columns. And one thing to note about array declaration with NumPy is if you want to add like a new row, you basically have to put these brackets each time. So if you guys notice, like this is equivalent, like this array is equivalent to this down here. So you see like how we basically had to, each time we want to define a new row, we had to put a new set of opening and closing hard brackets. And then outside the whole thing, we kind of put this these 2 brackets to signal that's the start and end of the entire array. And then size is basically just multiplying the dimensions like we talked about before. So in this case, it's 5 times 1, which is 5. In this case, it's 4 times 2, which is 8. And in this case, we only put integers in. So that's why the array type is integer. And then one thing I was talking about, remember earlier, how tuples are array-like. So because of the how similar tuples are to arrays, you can just do this conversion or creating an array from a tuple. By the way, you can also do this for a list, which is why like NumPy functions really well with a lot of inbuilt Python data structures like lists and tuples. So you can create an array from this tuple right here, and so you have this original tuple, which has 1A, 3, and 2B and 3.5. And if we get that, we basically just get like an array of 2 rows and 3 columns, and we can get the size of 6 and into 2 dimensions. So I think this is a pretty brief introduction into how you can declare a NumPy array and how to get like the basic shape and size of it. And here we're basically going to kind of show you how you can basically like arrange a bunch of numbers into a list, or you can kind of reshape an array. So first things first, we're gonna show you how you can get a random numbers in a distribution. So you can use this np.random.rand function. So this basically just gets you random numbers, like I said right here, from a uniform distribution between 0 and 1. So if you guys know anything about like statistics, you know that a normal distribution is not completely uniform. Normal distribution is kind of set around a mean of 0 and a standard deviation of 1. So yeah, but basically these 2 functions aren't too important to know, but these are just like extraneous information for you guys in case you want to know. This is pretty important. So remember how we talked about like how we can use range with for loops? So if we want to say like get the numbers between 0 and 10 and increment by 2, we would say like range parentheses 0, 10, 2. So we get all the numbers from 0 to 10 incrementing by 2. Well, we can do the same thing with NumPy, but the benefit of doing this with NumPy is that it actually returns an array instead of returning like a list, which is what it returns if you just use a regular range function. So here we're basically getting all the so let's actually, instead of printing this out, let's set this equal to like some variable. So this temp array. And say we want to print this out. And get the data type. It's data type, right? So I want to print out the type. You'll notice that it's gonna print out. It's gonna be returned as an NumPy array. And basically, this is all it's also gonna return is it's gonna return every number between -10 and 10 by incrementing by 2. So the syntax is the same as a range function. It just returns a numpy array or nd array instead of a list. And here, this is a very, very important function, probably one of the most important functions in NumPy, which is Reshape. And Reshape is really, really useful when you're working with deep learning and neural networks. And the reason why is because a lot of times you're working with images, right? Like you're trying to get your algorithm to basically classify a bunch of images and figure out what they represent. So in that case, a lot of times you have to resize the images in order for it to work with your model. The reason being is if you have a really, really large image, right? Processing all the different pixels in the image is really computationally intensive. And if you don't have that kind of compute power, you have to resize the image or like resize the depth of the image in order to make it less computationally expensive. Anyway, back to what I was saying. So here we're getting all the numbers between 1 and 12, and we're basically saying take those numbers, 0 and 11, not 1 and 12, 0 and 11, and we're basically saying let's reshape that into a 3 by 4 matrix. So we're going to get 3 rows and 4 columns, and we're basically going to take this inbuilt function and reshape it. So this kind of makes sense, right? We get this like vector. So np.aRange returns this vector that's 12 by 1, right? And then we're taking that 12 by 1 vector. I'm sorry, wait, no, it's 1 by 12. It's 1 row, 12 columns. It's 1 by 12. And we're basically reshaping that into having 3 rows and 4 columns. And we might use this for something else later.
Andre?
Yeah.
What if like it didn't fit like a 12, like what if like you said in range 12, but like it didn't fit? Like for example, if you did like 2 and 8.
It would throw you an error, I'm pretty sure. Okay. So if you like try to reshape it to something that doesn't work, it's gonna throw an error saying cannot reshape array of size 12 into shape 2 by 8. Does that make sense?
Thank you.
Yeah. So anyway, moving on. So now there are a few kind of mathy things here. So if you know a little bit about math, you know there's something called identity matrix. And you can get that by using the np.I function. And if you want to get a matrix of 1s or 0s, this is how we do it. The only really important thing to know from this cell is that has how to get a matrix of 0s. Reason being is a lot of times you have like a array. You want to kind of instantiate an empty array basically, and you kind of want to fill it with all 0s initially. So what you do is you just do np.zeros and then put in the kind of shape you want. So for example, if you wanted to have 2 rows and 3 columns, you can put it like that. One thing I want to point out in terms of syntax is for np.zeros and np.ones too, you need to kind of put this inside like a double bracket, if that makes sense. I mean, a double braces. So you should like, if you're trying to basically pass 3 rows and two rows and 3 columns, you basically need to put like a separate set of kind of parentheses that hold both the values. So if you guys think back to like the result of the shape function, it basically passes like a tuple back or like a parentheses like something back, which is basically a tuple. And in this case, you're basically passing the shape of the matrix as a tuple back to the np.zeros function. So just kind of make sure you have that extra layer of parentheses surrounding it. Anyway, so here, like I was saying, NumPy is made to be a mathematical library. So there's obviously going to be a lot of math functions that like work well with NumPy. So if you want to add like values to each, by the way, this is addition element wise. So for example, if you do x plus 1, you basically add 1 to each of the elements. Subtraction, you remove 1 from each of the elements. Multiplication, you multiply the elements. So basically, what I'm trying to get at is that all of these operations are all element-wise operations. So yeah. So this is useful if you have like a lot of data and you're trying to figure out like what values in that data are even or something. Instead of having to use a for loop, you can just pass that data as an array, as a NumPy array, and then use one of these convenient functions, mathematical operations, to basically figure that out. And here we got some cool operations where you can do the same operations we mentioned here, but instead of doing it between like a scalar value and like a NumPy array or a constant, we can do it between 2 NumPy arrays and get the same results. So this is also pretty useful. And yeah, that's kind of all I want to talk about that. Now, let's quickly talk about indexing and slicing with NumPy arrays. So like we talked about earlier, it's pretty similar. The slicing and indexing with NumPy is pretty similar to what you see with like strings and like lists and stuff like that. But oh, so this is actually an interesting example. So I think like probably the second week, Victor brought up a good point, which is that if you, for example, take like a slice of another array, right? There's still going to be a pointer to that subarray, which basically means that if you modify, say you say, so look at the example right here. So we take a slice of X, and then we're basically modifying the value inside of Y to something, right? But modifying this value will actually change the value of X. So we start off with this as what X is, and we basically slice the indices 3 to 5. So 0, 1, 2, 3, 4, and 5. So we basically get -2 and -1, right? And we're basically just this colon inside the braces means we just get every value basically. So we're basically resetting all the values inside of Y, which is just -2 and -1 to 1000. But if you go back and print X, we basically see that inside of X, these values have also changed. So how do we avoid this problem? Well, we have to use this function called .copy. So I think someone mentioned this a while back too, where you can, instead of having to take a slice of an array by basically passing, or instead of duplicating an array by taking a slice of the entire array, you should instead just copy it. And what I mean by that is like this. So say we have X again, right? So let's run this out just so I have a reference to X. Right, so we have X as this array, but say we want to basically set Y equal to X, right? So instead of doing this, we should do something like this instead. Because if you look at this, and then so we set Y equal to the entire value of X. So basically duplicate X into Y, but there's still a pointer reference from Y back to X. And this basically means that whatever changes we make to Y will basically also be changed in X now. So if you want to avoid that, like we were saying up here, use the copy function to make a copy of the subarray. And now if we modify the value, it's not going to change the initial array. Does that make sense? This is kind of like a technical, like general computer science thing. Like you guys probably saw this in CS2 at some point with like objects. So this is like not Python specific or anything. This is like across all languages. But this is just how you would fix it in Python. You use the copy function. Okay. So here, so slicing. So when you have these kind of 2D arrays or basically anything more than one dimension, slicing starts to get a little bit more advanced. Then we start to have two-dimensional slicing. So here, we basically are trying to get for example, if you take like this third print command, right? We're basically trying to get the third row. We're trying to get all the rows, but what's in the second column of each of those. So, and what I mean by that is basically, so we have this two-dimensional array, basically, or two-dimensional matrix, which has values 1, 2, 3, 4, then 5, 6, 7, 8, then 9, 10, 11, 12. So, the first thing that I think is important to note is when you use like NumPy arrays, if you just pass one parameter, right, it's automatically what NumPy is going to do is it's automatically going to think that you're trying to access that at the nth or whatever parameter you passed here. So for example, the second sublist, and we're going by zero indexing, for example, in Python. So for example, the second index would be the third list or the third sublist. So what NumPy is going to think is like, okay, this guy is passing me this 2 as a parameter, or the second sublist. So if it goes 0, 1, 2, the second sublist is this. But if we go by like the way we think of like accession in Java, where we have like that rows, hard brackets, columns, with like our matrices in Java, it's actually going to be a little different. NumPy is not gonna think of it the same way as we think of it in Java. So this is important to point out. So instead of getting the second row here, which would be sorry. So yeah. So instead of getting the second row in the second example, instead of getting the second column in the second example, we'll be getting the second row again, which is why you can see this in the print statement down here. So 9, 10, 11, 12 is printed for both of these print statements. Does that make sense? I don't know if that explanation was a little confusing, but basically what I'm trying to say, reiterating what I'm trying to say, is that with NumPy, it's going to basically think that if you don't pass like an explicit, column parameter, it's going to think that you're trying to access the nth sublist, and the sublist is basically each of the rows that you're trying to pass. Okay, and this last statement here is important to note. You can't access NumPy arrays through this sort of indexing where you have this rows, comma, columns in a single bracket. And the reason why is because each of these brackets basically designates like a layer. So what I mean by a layer is like if you have this, so if you start off with this entire array, right? And then you basically can dive into the array one layer at a time. And what I mean by that is, in this case, we can first access the array by saying, okay, I first want to get into the first sublist, or 1, 2, 3, 4. So that's the first layer of like accession. And the second layer of accession would be grabbing one of the values, or like a subset of these values that are found in the first row or the first sublist. So that's what I mean. So in this case, we have a 2D list or a matrix, and we have 2 levels of accession. So you should always have, if you're specifying all of the dimensions, you should always have the same number of brackets as a number of layers of accession. So if you don't specify a layer of accession, for example, here we only specified 1 layer instead of 2, like we did here, NumPy is automatically going to assume you want the entire thing of the first layer that you didn't access. So in this case, NumPy is going to automatically assume we passed this, even though we didn't pass that. So if you want to make a change to that, we have to like pass a subset of this. So we can pass like that or something, the first value or the first sublist. And if you go down here, we see that now we're working with a NumPy array. So there's nothing too important here. I think we've covered all of this stuff right here. But yeah, this is kind of self-explanatory. You guys can come back and look at this, but this accession is the same thing as what I talked about up here. Okay. So now NumPy array also supports indexing with booleans. And basically what that means is that we can use a boolean statement to basically get a subset of an array. So here we basically take all the values from 1 to 12 and we reshape it into a 3x4 matrix. And then what we say is, let's grab all the parts of the array that are divisible by 3 or so, or basically what this is saying is when you divide the value by 3, you get a remainder of 0. So basically the values that are divisible by 3. And this basically goes element wise. So when you have like a boolean like this, where you say like the entire array mod some value, if you remember going back up to here, this is element wise mathematical operations. So it's gonna basically go through each of these elements and check if it's divisible by 3. And for example, the output we're gonna get is gonna be 3, 6, 3, 6, 9, 12, because those are the values that are divisible by 3. And as you can see, the data type is still going to be a NumPy array. Okay, so now we can make it a little bit more complex. We can basically say, let's only look at the values in the second, from the second row onwards. So if you take a look at this, we're basically saying, first, let's only look at the second row and onwards. So we're only looking at this row right here, right, or the third sublist. And we're basically saying, for that third sublist, check all the 4 values and return the values return the values that are divisible by 3. So if you go here, we basically are saying grab. So when we're doing the modulus checking, right, we're basically only grabbing all these 4 values by saying we're gonna get the second row and all the values in that column. Sorry, all the values in that row, and we're basically the element-wise operations only going to be applied to this row. So that's why the result's only going to be 9 and 12. All right. Okay, I think this is an important point. This is something important to show. So we can also pass indices as kind of a list of a list. And what I mean by that is if we, for example, want to grab a certain reordering of the rows, we can pass the indices of the new ordering that we want, and then pass that to the NumPy array. So in this case, we want to grab the second row and make it the first row. We want to make the first row the second row. All right, wait, can you guys see my screen or did it crash?
It crashed.
Okay, wait, hold up. Okay, now can you guys see my screen, right? Okay. Yeah, so what I was saying here is when you have the second row, for example, you're basically just mapping out the reordering of the initial indices to rearrange the rows. So this is kind of like a fast way to do that. You make a list that contains the new ordering that you want, and then pass that back as kind of a slice of the original. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But then what we're doing is we're grabbing the third row and making it the first, and we're grabbing the the second row, and keeping it as the second. And then we're taking the first row and making it the third, and keeping the last row the same. And then here we can actually do the same operation to the column index. So in this case, we're basically doing that for all the values. So we're basically reordering both the row index and the column index, and uniquely printing out that output. So yeah. Don't think there's anything else. So this is all just, the rest of this is just all like math. So I guess it's familiar. It might be good for you guys after the class today, or after like the meeting today, to go back and look, just not memorize, but like look through these functions, because some of these are sometimes handy, but like they're mostly just like if you forget, like for example, how do I get standard deviation with NumPy? You just Google it, and then it tells you, okay, it's np.std. So like things like that are just like Google it. Like I probably off the top of my head, I didn't even know about some of these functions. So yeah, like none of these are like super important to just know. You can just Google them. So I'm gonna skip these next 3 cells. Here is some matrix multiplication. So how many of you guys are familiar with like this notation, or like transposition in general, like matrix transpose? I don't know. Should we even go over that? I guess you guys can just. Well, I'll put a link. I'll put a link in the drive to a useful resource for that. So let me write a reminder for myself. So I want to post a link to a matrix multiplication website that explains how these operations work mathematically. But I think that it's probably not worth our time to go over it right now. Okay, so now we finished like our basic introduction to NumPy. Does anyone have any questions before we move on? Any pending questions? No questions? Okay. So now I'm gonna unshare, and we're going to quickly transition over to talking about Matplotlib. So the first two things I want to show you are these cool things that Sam found one of these and I found another one of these. Basically what these are they're kind of cheat sheets for Matplotlib and this other library called Seaborn. So I didn't even know about these, but I found them yesterday when I was looking for some material. So basically this is made by something called datacamp.com, some website. Basically it goes over like a lot of the important plotting routines and plots that you can make with like Matplotlib, and there's also one for something called Seaborn. But yeah, so I'm gonna post these two also on the drive so you guys can take a look at them and like I guess keep them handy in case you might need them. I don't know why you specifically need these, but yeah, I think they like summarize the material really well in like a quick page. But yeah, so and there's actually one for Seaborn too. So I'll quickly introduce Seaborn. So Matplotlib is a Python 2D plotting library which produces like figures that are really like clean and nice in a variety of formats. And Matplotlib is basically like the standard like visualization or plotting like library in Python. So if anyone asks you like what do you use, like what do you make plots from in Python, everyone's gonna either say Matplotlib or they're gonna say Seaborn, which is basically just a visualization library that's built on top of Matplotlib. And it basically is the reason why it's like better than Matplotlib for certain things is that it handles like data frames like works with pandas more easily most of the time, and it's also a more high level interface, so it's not as low level as Matplotlib. So it's basically just something that's built on top of Matplotlib and is more high level. But you can also make like cool plots like a violin plot and yeah, things like the violin plot are pretty like cool you can make with Seaborn, and they're oftentimes a lot harder to make with Matplotlib. So those are the two visualization libraries we're going to be talking about. So let me pull up an empty notebook and we'll start talking about Matplotlib. All right, so all right, so let me reshare my screen. Okay, so I guess you guys can follow along with me if you want, because I'm going to be kind of typing as we go along. But essentially, oh, what's going on? Okay. But essentially, Matplotlib, like I was saying, is just a 2D Python plotting library. So if you guys have used like MATLAB or like some other programming language, you guys might have seen like a more familiar version of this. And it basically is just used to visualize data, identify like specific trends, and the most important point is to identify outliers of data. And this is really important, especially in like data science and machine learning, when like cleaning your data and making sure that you have accurate and relevant data is really important. And plotting what you have is a really easy and fast way to ensure that. So first thing, let's import few libraries. So import NumPy, pandas. Let's import. Okay, actually, let me introduce a new type of import format. So before we've shown you the import like X library as something else, we could also say from this like big library that has sub libraries. So Matplotlib is like a bigger library. You can like say like import pyplot, which is like the one we use, as like PLT, or you can say like import matplotlib.pyplot. Okay, so like both of these are valid declarations, so both of these work fine. But this one is kind of used if you are importing a lot of libraries, a lot of sub libraries. Then you can say like from Matplotlib import like pyplot, blank, blank, blank. But if you just want to import like one library, use this bottom declaration more often. So yeah. Anyway, let's get into it. Oh, let's also import one more library. I forgot. Let's import Seaborn and SMS. Right, cool. So first things first, let's basically create an array. And let's work with that array. So let's create an array called r equals np.array of 1, 2, 3, 4, 5. At 5 values, it seems pretty even and nice. So let's print out a. Oh, oops. I mean r. The array, and we get what we expect. So now let's make the simplest plot ever. We basically just say plt, and then this is the first function. So plt.plot a. And the next thing we do, whenever we make a plot, the next thing you always do with Matplotlib is you do plt.show to basically visually show it on your Jupyter notebook. So let's make the plot. Oh my god, why keep writing A instead of R? Okay, so we basically just get what we expect, right? We get a line that basically just has all the values on the x and y axis. So let's actually quickly use the help function we talked about a while back to look at this plt.plot function. So let's take a look. So there's a lot of different parameters that we can pass, right? So the first parameter is going to be like a array-like or scalar quantity that basically holds the coordinates of data points. And you can also specify like character styles, line styles, colors, and also like some filtering things to only use some of the data. So in general, there's kind of a lot you can do with just plt.plot. But anyway, that's kind of the most basic thing you can do. Create an array, and then just plot the array of values, and you'll get like a perfectly straight line, a line with the slope of y equals x, because both the values you're plotting on both the x and y axis are the same. So now let's actually create like a 2D array now, right? So it's actually creating a 1D array. Create a 1D array. Here now we're going to create a 2D array. So actually no, let's actually create 2 arrays first. Create 2 arrays. So the first array we'll call it A, or yeah, I'll call it A. And we're gonna make it like we're gonna make it 1, 2, 3, 4, and 5 again. And then we're gonna make an array B, which is like 6, 6, 6, 6, 6. Okay, and now let's plot A comma B and show it. So now we get what we expect, right? We see that we're putting A on the x-axis and B on the y-axis, and we're getting kind of this horizontal line because all the values we passed here were the same. And yeah, so that's how you use Matplotlib when you have multiple variables. So now let's actually make a more complex plot. So let's kind of have let's have like 3 let's make a plot where we have 3 kind of sub lines on it, or like 3 lines in the plot, and then we have like a figure legend and stuff. So that's like a more complex plot. So let's make that. So let's redefine A as actually let's keep A the same. Let's redefine B as 1, 3, 5, 7, 9 values, right? It's 5 values. Cool. And let's define C, a new array, as I don't know, 4, 7, 5, 6, 3 or something. And now let's actually add another thing here. So now I'm going to show you how to increase the figure size. So say you want to make the size of the figure that you're making bigger, or so increase/decrease figure size. You basically use this plt.figure parameter, which is basically going to allow you to specify this function, which allows you to specify this parameter called fig size, which is basically the size of the figure. So you can specify as like 15, like 5, or like let's make this like 10, 10 or something. And then now let's basically plot each of these functions. And assign them like a specific position or label on our legend. So let's plot A, and let's give it a color. So remember, color is another one of the functions. If you go back to the documentation, we talked about how color was another function that we could pass, or another parameter that we could pass. So let's make this the color red, okay? And then we can also give it another parameter called line style. And basically, line style is just like how you want the line to look. So you can like, if you guys like think about like graphs that you might see in like a history or like history AP, for example, like, you know, I'm sure you guys have like seen like graphs that are like have like different line styles on them. And what I mean by that is like they're either like dotted, or they're like they're like straight, or something like that. So basically, we can specify that line style to be like this, where we basically have like lines followed like a dot, followed by another line, and then dot. So let's make that the line style, and then let's give this a label. So let's call this array A. Okay, now let's do, since I'm too lazy to actually, instead of doing that, let's actually use new parameters for each of them. So for B, let's not specify a color. Let's just use a different parameter. So in this case, we'll use line width. So now we want to make the line width like bigger. So you make it like 6 or something. And then we'll give it a label. So we'll call it array B. We won't change any of the other parameters. And then with C, we'll give it another color. We'll give it blue, color blue, and we'll give it a line style again. In this situation, we'll give it this style. And then we'll give it a label of array C. And then of course we can always let's put a title on our graph. So we do plt.title for that, and let's call it plot of our favorite arrays. Yeah. So yeah. And then we can obviously change like the font size of this. So let's make the font size of this like 15 or something. And then let's also add a legend, obviously. So we will add a legend to the upper right. So location is upper right. And then we will give it a font size of 15 also. And then lastly, we will give our x and y axes titles. So plt.x label, and then we'll say x-axis is our label, and then for the y-axis, we'll say this is the y-axis, and then finally let's show this entire thing. Oh, what happened? Oh, apparently this is not a supported type. Okay. My bad. So this line style is not supported. The only line styles that are supported are like dashed, double dashed, dash with. I was trying to do this one, so you don't put an underscore. You just put a. Oh. I put an extra one here. Okay, cool. So now we have a kind of plot. And this plot is just like what you'd expect, right? We're kind of plotting everything on the y-axis. The values on the y-axis, and the x-axis is just like arbitrary. So the x-axis is just the position or the index of these values in the array. So this exercise isn't really to like work with real data. It's just more to like learn about the different functions. So now let's make some scatter plots. So, okay, so if you think back to us and how we use like the arange function like about 20 minutes ago, you guys remember that we can do something like this, and we'll now have a as like as a numpy array from all the values from 0 to 29, and then we can make b, which is going to be the second axis that we're going to plot, we can make it that random function we saw earlier. So np.random dot rand integer between 0 and 20, and then we can plot oh, my bad. So by the way, the mistake I made here was I only passed 2 parameters. I said I wanted a value between 0 and 20, but I only said I want to get one of the values. So that's why I got an error. But in this case, I need to pass a 3rd parameter. And now we'll have a graph. So this is a line plot. So whenever we say plt.plot, it gives us a line plot. But now let's say we want a scatter plot. So scatter plot is just all the points being like plotted individually, and there's no line between them, right? So we do plt.scatter, and then plt.show. Oh. Okay. So here we have the scatter plot. Looks cool. All right, moving on. So next, let's actually look at bar plots next, right? So we do scatter plots here. And now let's get bar plots. So first thing, let's create a series of categories, or like I guess like each bar has like a separate like identity or like reason or category. Because you usually make bar plots when you have like I don't know, like a number of different categories, right? Or you have some sort of ordinal variable, or you have some sort of ranking, right? And in general, when you have those types of plots or that type of data, you want to use a bar plot. So let's make categories. Let's make them the different levels of CS Club, right? Or the different parts of CS Club. So you have novice, advanced, and then we have like the ML subclub, right? So, and let's plot this against the number of people that we have in each, I guess, group, each club. So let's make people equal to, say 15 people in novice. I think that's a good estimate. 25, and then about 10 to 15 people. So we'll say 12 people in ML subclub. And now we'll just plot it. So we'll do plt dot bar of right. So yeah, we just plotted a bar of the novice, advanced, and ML subclub people. And what we basically are, one thing I want to explain here is that the reason why I set this xticks function or xticks parameter is because I want to set the labels to be the categories rather than them being 0, 1, and 2. And generally, when you create bar graphs, you have to, with Matplotlib, so not with Seaborn, with Matplotlib, you generally have to do this in 2 steps. You generally first have to plot the bar or plot the y-axis against like an integer ranking, and then you replace the integer ranking or the xticks, these different ticks, with what the appropriate category should be. And you do this, and you can do the same thing with the y-axis. You can do plt.yticks and change the ranking. Yeah, so I think that's all I kind of want to show you with Matplotlib. And then now let's quickly go over a few Seaborn stuff. So I think I have a pre-done notebook for Seaborn, so let's go take a look at that. Let me go find that really quickly. Actually, no, I think I have a Seaborn example at the end of this thing. All right. Cool. Okay, so actually going back to this previous notebook, there's actually an exercise at the end that I think we should do instead of covering Seaborn today. So I have this, we're going back to the same notebook, Introduction to NumPy and Pandas, and now we're going to quickly talk about plotting data from data frames. So like I was mentioning earlier, you usually use Seaborn to plot data from data frames, and you don't really use Matplotlib, but just for the exercise here, we're going to use Matplotlib instead. So the first thing we're going to pass this first thing at the top, which is like Matplotlib Inline. And basically, this is just saying that like you want everything to be shown like in the Jupyter notebook in the interactive environment. So if you do this, you usually don't have to say like plt.show. You can just kind of put this at the beginning of your notebook so that your Jupyter kernel knows that it should display it directly on the interactive session. So first thing is we're going to create a series. So can anyone tell me what a series is? So what's the difference between a series and a data frame? So going back to last week.
Like 1D versus 2D.
Yeah, basically. So series are just 1D columns, and then data frame is multiple series put together. So here we have a series, and we're giving it an index. So we're basically assigning some sort of value. I don't know what value this represents. Maybe it represents like change in like temperature or something. I don't know, but that's what it looks like to me in the data. So you have these different values assigned to each of these days from January 1st to 7th. And the first thing we do is we create a series from that, and then we plot it. So we say the kind is line and the title is line plot. So here they're not using Matplotlib. They're using the generic Python plot function and specifying that they want to use make a line graph and make the title line plot. And here you can kind of just specify the types of graphs by just using this kind parameter instead of having to say like plt.bar or plt.scatter or plt.plot. So plot obviously gives line plot. So that's kind of the advantage of using this instead. And here, so you plot a bar plot now with the same data. So instead of having as a line plot, you have as like a bar plot going up and down. And you can also make a histogram. So a histogram is like basically just like some categories or some like indexing on the x-axis, and the y-axis shows frequency, always shows frequency. So histograms are usually used for like test scores, or they're used for like looking at the number of something that you have, basically. So histograms are probably the most important thing, I would say, most of the time when you're working with imaging data. Because a lot of the time, the first thing you do when you have imaging data is to look at like how much of each class or category you have. So say you're like, think of like a medical problem, right? So say we're trying to diagnose people who have brain cancer, right? Usually what we do is when you get images of people that have brain cancer and don't have brain cancer, we can make a quick histogram looking at like how many people have brain cancer, how many people don't have brain cancer, and then maybe there's some other categories. We can just kind of visualize it easily. And then we can also do something on top of that to use a histogram to figure out the number of the average like pixel values when I say pixel values, I mean the pixel intensity. That's the word I'm looking for. Pixel intensity of those who have brain cancer versus those who don't. So you can use histogram for a lot of like things within the context of data science or machine learning. So here we're gonna make another plot histogram. Oh, I didn't even run any of these cells, so let's run this. Oh, not right. Import. All right. Just viewing all of these, and we expect. So here we are basically we're basically using the same plotting thing that we saw before, but now we're making something called a box plot. So I think you guys might know a box plot. It basically shows you like the mean, and then also shows you like the standard deviations, or like the quartiles. Sorry, not standard deviation, quartiles. And you can, so basically here we're making a tuple list with different dates, and we're showing precipitation. So it's not temperature, this shows precipitation. and we're basically showing the year, the temperature, and the precipitation at that year, and basically making that into a data frame and passing the column names. And then at the bottom, we're basically making a box plot, but only plotting 2 of the variables in the box plot. So say we wanted to plot the whole thing, we just remove this right here, and we get a different plot. We get I guess oh wait, yeah, wait, never mind. We don't want to plot the year because then the year would throw off the box plot. Never mind. So we don't want to plot the year. So we only want to plot the temperature and the precipitation. So that's kind of how it looks. And we're plotting the precipitation and temperature on the same kind of scale, which is kind of which doesn't really make sense for what we're doing, right? Because why would you plot 2 different values that are on different scales using the same like scale? So I don't really know why I did this or why I made this example, but anyway. So lastly, we have some data exploration. So this is gonna be we're gonna look at this. This is gonna be like the homework thing / we look at the beginning of class next week. And just for reference, next week we're gonna have a project. So next week's not gonna be a class, so like a teaching class. We're gonna have a project. So it's gonna be like you guys just working kind of, and like me and Sam are just gonna help you whenever you guys need help. But basically, there's this question, and I made this question, and then you guys will kind of have to fill in the code to do what I asked you to do. So yeah, I made a quick question here, and I will keep this up. But right now it's already 4:15, so I don't think you guys will be able to finish this today. But I will put up this notebook on the drive, and then if you guys can finish that by next class, and then we can go over that at the beginning. So that's the plan.